All right, guys, so we're going to be going over target 6.1. I can describe a graph using its key features. So the shape, increasing and decreasing, and special points. So key graph characteristics, just to expand those a little bit. We have the graph shape. So we have some names that we're going to talk about: lines, parabolas, absolute value, square root. We're going to hopefully be familiar with all three of these shapes and be able to identify it. If you don't know the name, if it doesn't maybe fit one of these categories, then describing it in words. What does it look like? Increasing versus decreasing. So we need to make sure to describe whether a graph is increasing, decreasing, or both, and how. Remember, we always read graphs from the left side to the right side. So you start on the left and follow the graph. Is it going up, increasing? Is it going down, decreasing? And then we have our special points. We have the maximum, the minimum, the y-intercept, the x-intercept. Some graphs may not have some of these points. They may have all of them. It just sort of depends, okay? All right. Now we're going to talk more in depth here about these four shapes that we have. So we have the line. So here's a nice linear graph or a line. Straight, right? Doesn't curve, doesn't turn, just one straight line, keeps going forever in both directions. That's another important observation with these. Generally, our graph, if it runs off of the pictured graph, we have to sort of assume that it keeps going in that general direction forever. But a line will keep going in a straight line forever. Then I'll move over here. We have the parabola. We have a few parabolas pictured here. Parabolas can open upward. They can open downward. They can even open sideways, though we are not really going to focus on those in this class. But this one over here is open up, right? You can see the arrows pointing up on both sides. It's got this general sort of U shape. It has a minimum in this case, all those different things. And then we have this one over here. This one is opening down because the arrows are pointing down on both ends. We'll talk more about parabolas when we see an example here. And then we have the absolute value graph. So this is an absolute value graph. It has this kind of V shape. It has two lines on either side and it turns. So while the graph is straight, it's not straight forever. It does make a kind of turn and go the other direction. Absolute values are always going to have this V shape. Now they could also open downward like this, similar to the way that parabolas can open downward. And then we have our last graph here, the square root graph. Square root graph is kind of special. It's created using the square root operation, but if you notice, if we kind of like fill in this symmetrically, it's kind of like a half of a parabola. So if I draw this here, you can see this kind of symmetry that's going on. If I draw the other side in, it looks like a sideways parabola. And that relationship is actually true. Mathematically speaking, but it's kind of a funky looking graph. It starts at one point and then just kind of curves away from that. Notice how it's not really straight. It is curving and it is still going kind of up and to the right forever. All right, so we need to be able to look at a graph and decide if it's one of these four things here and give it that name if it does apply. The next thing to talk about is increasing versus decreasing. Some graphs may do both. And we want to talk about how we want to discuss that as well. So increasing is going up as we follow the graph from left to right. Decreasing is going down as we follow the graph from left to right. So here, this picture here, there's a line, right? We're a straight line. As we start on the left side over here and we follow it, right? We follow it to the right. What's it doing? Well, it's generally has a downward trend. Starts up here on our left side of our graph, and as we go, it is actually getting lower. So this is decreasing. This one is decreasing the entire time. There's always temptation here. The place that people get confused is this arrow. Just because there's an arrow on this end and it's going up over there, that does not mean that it's increasing, because that is following the graph in the wrong direction. That's following it from right to left. That does not mean that it's increasing. You always look from left to right, just like you read words on a page. So this one is only decreasing. All right. And this was, again, a line just to reiterate some things we've talked about before. Here we have a parabola. Parabolas are a little bit tricky because actually they're doing both. There is always the temptation to say, well, it's going up on both sides. This is an increasing graph. That's not true because on this side in particular, if we go up over here, that's actually following the graph again from the right to the left. We're going to the left. That's not the way we read it. We always want to start on the left side and move to the right. So we start over here. And what's happening at first here, right? What's happening? Well, we're starting by actually decreasing. So this first section of our graph is decreasing. And then we turn it around. And then we start increasing, following it from left to right. Now, you can get really technical with this in terms of your description. You can say it's decreasing until this spot right here. And in general, we just describe the x coordinate of that. So we could say something like decreasing until x equals -1, right? That's the x coordinate there. Then increases, or then increasing. I would also be okay at this stage of our learning on this is just say it starts decreasing and then it turns and it's increasing. Something like that would be fine too. Again, both things can happen in the same graph. It can increase and decrease in different parts. All right, now let's talk about the key points or special points here. So we have minimums, maximums, y-intercepts, x-intercepts. Minimum is just the lowest point on the graph, though. We're looking up and down. What is the lowest point on the graph? Maximums is the highest point. The thing to pay attention to here is not all graphs will have even one of these things. And a lot of times if they have one, they won't have the other. So just because a graph doesn't have a minimum or maximum, that's not a problem. Or if it has a minimum, it's likely not going to have a maximum. If we just sort of sketch out, let's just look at a parabola here, right? Here's a generic parabola. This graph does not have a minimum because these arrows tell us the graph is going down forever. Therefore, there will be no lowest point because it's going to keep just going down lower and lower and lower. But there is a highest point right here. This is the top. So this would be a maximum. Another type of graph that we'll look at a lot is a line. A line actually doesn't have either, right? Because there's no highest point because it's going to keep going up forever. And there's no lowest point because it's going to keep going, well, down forever on this side. So there's no highest point, there's no lowest point. So there's no min or max, no min or maximum. So, we can have one, we can have none. Can we have both? There are some really special graphs that could have both, but for the most part, the ones we're going to look at are going to have either a minimum or a maximum or none. Okay. And then we have the x-intercepts and the y-intercepts. So just a brief reminder, right? The y-intercept is where the graph crosses the y-axis, and the y-axis is our vertical axis, and the x-axis is our horizontal axis. So let's just kind of label some things out here, right? Again, this one, the green one is the y-axis, this pink one is the x-axis. Whatever graph we have, it could cross both of these things. So we could have a line, a pretty simple line right here. It's going to have both. It's going to have a y-intercept here. We need to know the coordinates of that particular point, and it could have an x-intercept right here. Again, we want to know the coordinates of that particular point. So that's one example of a line is probably going to have both. We could have a parabola, for instance. So a parabola could go down here and then kind of come back up, and a parabola actually crosses the x-axis twice. So there are two x-intercepts, and then it crosses the y-axis right here, and there's one y-intercept. A parabola could also get really interesting, and it could do something like this. It doesn't cross the x-axis at all. Is it going to cross the y-axis? It's hard to tell. It's not quite sure, but we have to know that just because, we can only see this part of our graph we have to assume that it's going to keep going forever. And eventually, you can see how it's getting closer and closer to the y-axis. Eventually, at some point, it will cross. So there will be one somewhere here. You know, it's really important to note that just because what you see on the graph is all that you see, you have to be able to visualize what's happening beyond it, and if you need to investigate that too. Anyway, in general, graphs are going to have y-intercepts and they're going to have x-intercepts, but there are some times where they may not have them, and you have to be aware of that. All right, let's go ahead and try to put a lot of this stuff together. So here's a graph. This is an absolute value graph, and I have the points all sort of labeled here. We have our x-axis, which is this horizontal axis right here. That's the x, and you can see the two x-intercepts are right there. And then we have the y-axis right here, this up and down one. Label it green here, and you can see where it crosses there. Notice the way that these points are written. So my x-intercepts here are written in this way. They have an x-coordinate, which is a number. That's the number where it crossed the x-axis, and the y-coordinate is 0. Because to get to these points, we don't have to move up or down. We're staying right along the x-axis. So the only number that's part of their coordinate is really just the x-coordinate. So it's -1, 0 here, that's this one, and 5, 0, that's this one right here. Whereas that same idea is a little bit reversed on this one, on the y-intercept, where it crosses the y-axis here. Our x-coordinate is 0 because we're not moving left or right at all. We're only moving up or down to find where it crosses the y-axis. So in this case, the only number that we have is a y value -2. And then we have, obviously, this other special point down here at the bottom of our graph, the lowest point, we have the minimum. The x-coordinate is 2, and the y-coordinate is -6. Let's just go ahead and get those arrows on there. So our x-intercept again right here. Notice how their y-coordinates are 0. We have the y-intercept. Notice the x-coordinate is 0. And then we have our minimum. There's no maximum to this graph because, again, when our graph runs off the screen like this, we have to assume that it keeps going in general in that same direction beyond here. So there's no highest point. It's going to keep going up forever. All right. So here we go. Now we're really going to throw it all together. We're going to try to do all aspects of this whole describing process. So here's our first one. Feel free to pause it and see if you can kind of come up with these answers. First of all, what is our shape? So remember, we have lines, parabolas, absolute value, square root. This is just a line, straight line. Increasing or decreasing? Well, remember, we read this graph from left side to the right side. And what are we doing? Are we going to be going up? Are we going to be going down? Or some combination of both? In this case, we're going up, right? Start over here on the left side, move to the right. We're only going up. So this is an increasing graph. We already know that there's another more specific language with lines. Just as a quick reminder, this would have a positive slope. Not important for us right now, but it's good to call back on those things we've learned in the past. Next thing, we're going to talk about our special points. So is there a maximum? Is there a highest point on this graph? The answer is no. This graph is going to keep going this direction forever, right? To the right, it's going to keep going up and to the right. So there is no highest point. So there is none. Is there a minimum? Is there a lowest point? Again, the answer is no. This graph is going down to the left here forever, generally trending downward there. So there's going to be no lowest point either. So no minimum. Last couple things here, we have our y-intercept and our x-intercept. So we want to find where these are. So our y-axis is up and down. So here's our y-axis. We want to know where the graph crosses it. It's right here. Remember, for y-intercepts, the x-coordinate is 0 because remember we started the origin, we're not moving left or right, so 0, and then we have to move, in this case, up to meet that that y-intercept point, so up 2. So x-intercepts and y-intercepts, remember, one part of their coordinate is going to be 0, and so for y-intercepts, it's the x-coordinate that is 0. There we go. That's that point right there. And then our last one, the x-intercept or x-intercepts. Our x-axis is this horizontal axis right here. We can see that it's crossing right at this point. And again, starting in our origin, x-coordinate first, we're going to the left 4, so that's -4. And then up and down 0, so our y-coordinate is 0 here. And looking at this, notice which part is 0 for each of these intercepts. That is important information. All right, let's go ahead and clear this, and we're going to do a couple more of these. All right, so again, feel free to pause this and try this on your own at any point. I'm going to go ahead and just jump to answering these. So what is our shape here? This is a parabola. Whoa, didn't mean to do that. This is a parabola. Some specific language for parabolas in this case. A lot of times you'll notice where the arrows are pointing in this case. This, you might say, opens down. That's some very parabola specific language. We don't really talk about other graphs usually in this way. But I'm going to go ahead and add that in right there. That's not necessarily expected of you, but it would be good to know. The next thing we have to answer about this is increasing or decreasing. Well, remember with that, it's really important we are reading it from left to right. So let's follow this, right? Start on the left-hand side, follow the graph. It's going up, right? It's increasing up until this point right up here. Then it's decreasing. So it does both. Now, in this special circumstance, you could just say increases, then decreases. That's fine. That would be accurate, but I want to try to be even more specific than that. Where does it stop increasing and start decreasing? And it's this particular point right here. So it stops increasing, which again, at this case, we talk about the x-axis. So it increases until -1, and then it decreases. Increases until x equals -1, then decreases. Again, we use the x-axis as kind of a way to gauge our graph because we're reading it from the left to the right, and the x-axis goes from left to right. So all these numbers over here, it's increasing, 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 and then it stops increasing at -1, and then after -1, it starts decreasing. All right. Let's go ahead and erase that stuff so we can talk about all of our special points next. So minimum or maximum. Again, not all graphs have these, and most of them will only have one. This graph has a highest point. Hopefully you can see that right here. This point here is a maximum. So what are the coordinates of that? Well, again, we start at the origin. We need to go left 1, which is -1, and then we need to go up 4, which is +4. So that is our maximum. Minimum, is there a lowest point? No, this graph goes down forever. So there will never be a lowest point. So there is no minimum. X-intercepts and y-intercepts. Now we're looking for where our graph crosses these axes. So there is a y-intercept. Again, our y-axis is up and down. It crosses the y-axis right here. The x-coordinate for this, again, is 0 because we are not moving left to right. We're only going to be going, in this case, up to our intercept, up 3. So 0, 3 is the coordinate of that y-intercept. And then x-intercepts, we actually have 2. There are 2 places where this graph crosses the x-axis, and I'll circle those here. For our x-intercepts, we are just moving left or right to get to those. So they're only going to have an x-coordinate. We're not moving up or down at all. The y-coordinate will be 0. So this first one over here, we're moving to the left 3. That's -3, 0. Okay, we're not moving up or down, so that y-coordinate is 0. The other one, we're going to move right 1. So that coordinate is going to be +1, 0. There we go. Check your answers against what you see here as you've tried that. Okay, let's clear this and keep moving forward. All right, so let's go ahead and talk about this one. So here we have, first we'll talk about the shape. We haven't seen one of these yet. This is actually a square root. Again, square root, it's not a line, it kind of curves. It has a starting point, starts here. There's no arrow here. We can see this graph, right? It's not continuing down here. It actually stops right there. That's important to know about square roots. And then it goes off to the right. And in this case, we do assume that it goes off to the right because it's running off of our graph. We can't see it anymore. It keeps going that way, but it stops here, right? Because we have more graph that it doesn't continue through. So it's important to note there. Is this graph increasing or decreasing? Well, let's start on the left side. We follow it. It's generally going up. So this is an increasing graph. Doesn't go down, just increases. Is there a maximum? Is there a highest point to this graph? Doesn't look like it, right? As we follow it to the right, it's generally creeping upward forever. So it is always going to be going up. So there will be no maximum, no highest point. But there is a minimum. There's this point right here. This is the lowest that it goes. So what is that minimum point? Well, to get there, we need to go 4 to the left. So that's -4. And then 3 down. So that's -3, right? You can see those coordinates. Let me just do it this way. -4, -3, right? You can see the coordinates on the actual grid there that way too. All right, last couple questions. We're going to talk about the intercepts. So what is our y-intercept? You can see where it crosses the y-axis up and down here. It crosses right here. Y-intercepts have an x-coordinate of 0 because we don't move left or right to get to those. We just go up or down. So we're going to go down 1, which means it's at -1. X-intercepts are kind of reversed from that. We started our origin. For this one, it's over here. So we need to move 5 to the right, +5, and then 0 up or down. So the y-coordinate is 0 there. And that's the only one. It only had 1 in this case. All right, let's go ahead and clear this and do our last example. You may be able to guess what type of graph it is if you've been paying close attention. All right, here we go. So here is an absolute value graph. This is an absolute value. It's this V shape. If you ever forget these, it's important that we know these names, but it's also important that we could just simply describe it. If you said V shape, that would be okay. Not perfect, but it would be okay. All right, let's go ahead and talk about increasing or decreasing now. So this graph does both, right? As we follow it, we start on the left side, it is decreasing up into this point right here, and then it turns it around, and now it starts increasing. So let's talk about that. It decreases until right here at -3. That's when it stops decreasing, right? All the way up until -3, it's decreasing, decreasing, decreasing. And now as we move on past -3, it starts increasing, increasing, increasing. We kind of talk about it in terms of the x-axis because we're reading it from from the left side over to the right side. So just make sure you're aware of that you are reading it in that way. Now, let's actually write that out. So it is decreasing until x equals -3, then increases. Here we go. And let's delete all that stuff that we have there. I think we'll erase it. Okay. Maximum, minimum, y-intercept, x-intercept. Let's go ahead and run through those. So is there a highest point here? Is there a maximum? No. No maximum. Again, we have to assume this graph keeps going up forever, so there won't be a highest point. Is there a minimum? There is. There's a lowest point right down here, right? That's the lowest point on our graph. The x-coordinate is -3, and then y-coordinate is -4. We went 3 to the left, and 4 down, and that's where we end up. Y-intercept. Where does this graph cross the y-axis? You can see it right here. Here's our y-axis. It's crossing at 2 on the y-axis. Our coordinate is 0, 2. Remember, because we're not moving left or right, we're only moving up. So that x-coordinate is 0, y-coordinate is 2. And then the last one, x-intercepts, we actually have 2 for this graph. We have one right here at -5 and one at -1. So our first one is -5, 0. And our second one is -1, 0. Again, remember which part is 0 when you're writing these intercepts out. All right, that's all. I'll see you guys in class. Bye.